right. As our last concluding video, you should have seen these 3 different phases of matter in the sim. And this is kind of a little animation to show you what you should have seen of how those molecules move in place or flow around each other or move around real crazy. And this is to kind of answer the section that you had, the questions that you had in the last section. It's more of in table format, but it just seemed more visually appealing this way. The first questions were asking you about substance A, which I went through with you. It was a solid, it was rigid, and it kept the shape of its container. And on the molecular observation scale, those molecules kind of vibrate in place. So I'm going to use my hands to compare them to molecules. They kind of vibrated a little in place like that first animation you saw on the last slide. Substance B, you should have seen, was a liquid. The macro scale observation that you could have made was that it flows, or that it stays at the bottom of the container, or that it takes the shape of its container. You then needed to make a molecular scale observation, and a molecular scale observation that I made about it was molecules move around each other. So get your molecules out. Say your fists are molecules. If it's a liquid, they're going to move around each other versus a solid just vibrates in place. Okay, put your molecules away. The next thing that you saw was substance C, or that you should have seen was substance C. That was representing a gas. That's the phase. And then the second question you had about substance C was asking you to make a macro scale observation and a molecular scale observation. The macro scale observation is that gas, you can't see it. It fills a container and it has no visible shape. For example, like I said yesterday, there's gases moving all around me, but I know they're there because I can breathe the air, but I can't see them. A molecular scale observation that you should have seen is that the molecules move away from each other. So those molecules, get your molecules out. Again, these fists are going to be representative of your molecules. If they're moving away from each other in a gas, they're moving like this. And don't punch any of your siblings while you're trying to model this. So again, solid, molecules vibrate in place. Liquids, they move around each other. Gas, they move all over the place. Okay, put your molecules away. So people don't think you're crazy. The next thing that you're doing in this activity, I'll move myself back down here. You're going to be looking at an online forum and trying to determine why the lake on Titan changed. But first, you need to know what happens to those molecules of a substance when it changes phase. So can anyone help you understand this? You'll have 3 different three different claims that you're looking at on this online forum. One is from someone who typed in from I Love Space. There's 3 different people that type their opinions onto this online forum as to what happened to the molecules of the substance when it changes phase. Claim 1 from I Heart Space says, I think that molecules in a substance disappear or no longer exist when a substance changes phase. I think this because when a substance goes from liquid to gas, I can no longer see it. Claim 2 is presented by someone called Planet Lover. They said, I think that molecules in a substance move differently when a substance changes phase. I think this because when you tilt the container, they are in a liquid gas and the solid do not move in the same way. Your third claim comes from someone called Science is Cool. They said, I think the molecules in a substance change into a new kind of molecule during a phase change. I think this because a liquid looks different from a solid or a gas. You'll see underneath this video that you need to tell me which one you think is right, and then you'll move on to answer some questions in your exit ticket. You're almost done. Keep up the good work.